In this movie, we answer this exam question, and in so doing, we revise the meanings of different orders of alcohol naming, and we get some practice in IUPAC naming, as well as in determining the minor and major product of an elimination reaction. If you missed the previous movie in the series of sub-questions of this larger question that you can download below, then make sure you click there to watch it. We're given this condensed structural formula. Let's expand it. I've partially started to expand it over there. Let's continue in that expansion. First of all, this bracketed part is actually a branch. It's a methyl branch because there's only one carbon in the branch. This carbon corresponds to that carbon, and there are 3 hydrogens attached. This is that carbon, 2 hydrogens. This carbon is attached to 2 carbons, the hydroxyl group and the methyl group. And then this is the end carbon here with 3 hydrogens. We're asked whether this is a primary, secondary, or tertiary alcohol. How do we decide? We take a look at the carbon to which the hydroxyl functional group is attached, and we count how many carbons are attached to that carbon. 1, 2, 3. It is a tertiary alcohol. Next, we need to give the IUPAC name of this alcohol. The first step in doing that is to decide on the main chain. The main chain, 1, must be the longest carbon chain, 2, that has the functional group attached to it. Now, in this particular case, there are 2 options. It could be this one, that is 4 carbon long, and it has the functional group attached to it, or it could be this one, also 4 carbon long, and also with a functional group attached to it. It doesn't matter which we choose, we would get the same answer in both cases, but let's choose the simpler one. Let's take that as the main chain. Because there are 4 carbons, this is a bute. Because the functional group is hydroxide, telling us that this is an alcohol, this is butanol. We also have to give the position of that hydroxyl functional group. And to do that, we have to number the carbons. We number the carbons in the main chain such that the carbon to which the functional group is connected gets the smallest number possible. If we start numbering from this end, that would be 1, 2, 3. Whereas if we start numbering from this end, it would be 1, 2. So clearly, that is a smaller number. The position of the functional group is on carbon 2. So that is butan 2-ol. Butan for the 4 carbons, 2 because the hydroxyl group is attached to carbon 2, ol because it's an alcohol. Make sure that you put that an in. Make sure that you put those hyphens in. That's not finished yet because we also have this methyl group, to which carbon is the methyl group attached, carbon 2. 2-methyl, butan 2-ol. Now we're asked about the major organic compound that will be formed when this compound undergoes elimination. We know that when an alcohol undergoes elimination, the 2 products are water and an alkene. Clearly, during that elimination of water, the hydroxyl group is going to come out. But the issue that we need to decide about is where the other hydrogen in that water comes from. Now, there are 2 options. It could come from this carbon. And if it does, that hydrogen will be replaced by a double bond at that position. The other option is that that hydrogen could go off with the hydroxyl. And if that happens, then that hydrogen will be replaced by a double bond at that position. Let's draw those 2 possible alkenes. First, if this hydrogen goes off, Notice how this part has gone away, so we don't have the hydroxyl there anymore, nor do we have that hydrogen. But since both of those carbons still need 4 bonds, the hydroxyl and the hydrogen are replaced by that double bond there. Now, how about if instead that hydrogen atom goes off with a hydroxide? So we see what's happened here is that that hydroxide has gone off with that hydrogen, and so as a result you can't see the hydrogen there anymore, nor the hydroxyl there anymore, but these 2 carbons still need to each have 4 bonds, and so those things are replaced by a double bond. So we can see that these 2 alkenes differ in the position of the double bond. Now, how do we decide which is the major and which is the minor product? Well, first of all, both of these will be produced. But the difference is that one will be produced in greater abundance than the other. The one that is produced in greater abundance is called the major product, and the one in less abundance, the minor product. How do we decide which is the major and which is the minor? There are different ways to decide, but the one that I find the easiest to remember is called the richer stay richer. Now, how do we decide which we're speaking about? Well, we go to the compound before elimination and we look at the potential contesters and we focus on the carbons. And by rich, we mean have more hydrogen. So this carbon here is richer than that carbon because this one has 3 hydrogens and that one only 2. So the richer stays richer and stays unchanged in the major product. So which one has that rich one unchanged? That one. You see there, that richer one is changed. Here it's unchanged. And that will therefore be the major product. That will be the minor. Now we're asked to give the IUPAC name of this major product. For the same reasons that this is 2-methyl-bute. This is also 2-methyl-bute, but then the last part is no longer applicable. So let's just start with what we already know. This is 1, 2, 3, 4. And the methyl is still on number 2. So it's still 2-methyl. But now it is not a butanol because there is no hydroxyl functional group. Instead, the functional group now is the alkene double bond. So it is now a butene. But we can't just write butene. We have to insert the position of the butene because you can see that that can differ. And certainly it does differ between the major and the minor, and we need to distinguish. So where is that alkene double bond? It's between carbon 2 and 3, so we write but-2-ene. Make very sure that you put in these hyphens. Also, it's not butan-2-ene. Just as you wouldn't say butanene, it's butene. So it's but-2-ene. Something for you to answer in the comment section below. What is the name of the minor product of this elimination reaction?